Okay, so I'm just going to go over how to install the PiMost drivers, known as SocketMost. I've written quite a good little walkthrough on the GitHub repo page, so pretty much this video is just going to be running through all of the steps that are listed in here. So the first one is to clone the repo. So copy that, open up a terminal window, and we will paste it in there. Next we got to change into that folder. Then we need to create the audio driver. So for people that don't know, MOST Bus is mainly based around multimedia, sending audio, sending satellite navigation directions, Bluetooth, microphones. It's all based around audio, whereas CAN bus is just purely data. MOST does have the same functionality in terms of data, so it can send a lot more data a lot quicker, but the main functionality of it is around the audio side. So what the PiMost HAT does is takes audio from the Raspberry Pi and directly puts it onto the MOST Bus network, onto the fiber optic network. So it does that at 48 kilohertz using external clocks, which is nice. So if we want to install the audio drivers, we just follow this one through. So first one is to change into the overlays folder. Then it is to build the overlays. The overlay was built using this repo that's got a link here. Luckily that guy did most of the work. So with them built, we just got to copy them over to the overlays folder. And then we've just got to edit the pulse audio configuration. So if we go back, we copy this line, paste that in, and then you want to scroll down until you see this block of text, which will be commented out by a semicolon. So if you go all the way down, so you see it's these ones here. So first thing we do is comment them out. Now if we go back, you can see they're slightly different. So MOST Bus runs at 48 kilohertz, not 44.1. So if we go into here, we'll just make sure these are both 48. And then when you're happy with it, Control X and then Y, and then press Enter to save. The next bit's for the CAN bus. If you want to use the CAN bus channel that's built into the PiMost HAT, you can install it through these commands. First we run an update, then we'll install CAN utils. So next bit to jump onto is the boot configuration file. So we want to uncomment these rows if they're commented, and then we want to add a couple of rows in. So if we copy that first one, paste it in. If we scroll down to SPI and I squared S, which is these ones, so you just want to delete the hash. And we want to add this line to the file. Pretty much add it wherever. I quite like doing it down the bottom just to keep it tidy. Then we also want to add this one. So if you've done this one before, this might look a bit weird. The fact it says CAN 1 when we really want it as CAN 0. When it does come up, it will come up as CAN 0. Just says CAN 1 there because it's the second device on the SPI network, the first one being the PiMost HAT. This last bit here is for the auto shutdown. So what the PiMost HAT does is when most network drops off, so when the red light drops off on the ring, it starts a timer of 30 seconds. After 30 seconds it completely cuts power to the Pi, lowers the consumption to about 0.5 milliamp. When it does drop off the fiber optic network, a pin gets pulled low, in this case 26, and by putting this into your boot configuration you can tell the Pi to shut down gracefully when that Pi goes low. There's a debounce timer on it, so this is 2 seconds. You could probably put that all the way up to 20 seconds if you want, because then that will give 10 seconds for the Pi to shut down before the power gets cut completely. It might be handy if you're just quickly stopping the car, starting it back up, rather than the Pi shutting down and turning on. This will delay that and give you a chance to restart the car. So you can kind of set that to whatever you want. That is in milliseconds, so 2000 is 2 seconds. If you want to put that in, you just copy it, and on a new line down the bottom you can just paste it in. I'm going to comment it out for now, just because while I'm developing and doing the video I don't want the Pi turning off when the MOST bus stops. With all of that done, Control X, yes to save buffer, enter, and that's most of the configuration done. So now we've got to go on to the software install. So if we change up 2 directories, or 1 directory, sorry, we can then need to install Node.js. So we copy that command and paste it. And we can copy this one. Paste. So yours will probably take longer. I've already got it installed in here. So if you, once you're done, if you type node-v, should return version 18. Now we can install all the dependencies for the drivers. So if we copy that one, paste that in. This one will take a little while. And with that one done, we can go back. Next one is to get the directory that we're currently in. So we'll need this to set up the service. If you've installed your operating system as a user other than Pi, you're going to have to replace all references to Pi with your username. So if we first run pwd, see that's my current directory. We can then go back into here, copy this one. So this is creating the service file. Paste that in. It'll bring up an empty file. Now we want to just copy all of this, paste it in there, and this is where if you have got different user, you change this one, you change this one, and you change this one. So you just change Pi for whatever your username is, which you could have got from the pwd command before. So we'll save it. Then we just need to enable the service. Paste that in, ask for authentication, so just put your password in, and then we can now reboot. Okay, so now it's all rebooted. We can check if the service is working correctly by copying this command. Open up a terminal window again. This is what you want to see. So this is saying it started SocketMost, config file exists, It's got a version number and a node address. Then it runs the configuration, and these are all the registers that are getting written to on startup. So with that looking good, if you're on a MOST network, or you're plugged into your car or a test bench network, you can now test to see if you're getting any traffic. So I've got my little test bench set up running, so if I come out that, then CD into SocketMost, you can see here my test bench set up. So I've got the Jaguar multimedia stuff here, I've got the Land Rover one there, I've got an amp, and I've got a couple of speakers. That's the Raspberry Pi. It's hooked in using one of these, which you can get off the website. It's a splitter, so it just takes the input to one of these devices, turns it into two. One of them is then plugged into the PiMost. So I'll just power that up, turn it on, and then on the Pi we can run node test.js. See, we're connected, and there are our first MOST bus messages coming through. So these won't make a great deal of sense if you're just starting out on this. It's just saying there's a new message, a message type of one, source address, and the data of the message, which looks quite empty there. So with it all running, we can close that down, and we can run this Explorer service. So this is good if you're on a network and you want to start seeing some traffic coming through properly. That probably means a bit more than this. It's an early version of it. It's kind of designed to be similar to a can dump, can utils. So let's start up the server. So if we write node explorer server.js, run that, it's saying it's connected. This is then the MOST Explorer app that I'll be releasing in the next few days. Again, super early version, like everything with all the MOST bus stuff so far. These are just the messages coming through, and they've kind of been formatted to make a bit more sense. So see, this is an F block of 1, instance of 2, function ID of 0, op type of 1, source address of that, and that's the data. So the data is empty. I'll do a complete separate video on how this protocol works and what these mean, but I can give a quick summary, brief overview of it. So this is one of the MOST cooperations data sheets. These specify function blocks. So function blocks are items such as these. So net block, network master, tool, audio amplifier, auxiliary, microphone input. There's a bunch of these, and each device can contain quite a few of them. So your CD player will obviously have the audio disc player one, but you'll probably find your amplifier also has an audio disc one, and that's just kind of shadowing the state of the actual CD player. So you can see the one we're getting through is a net block. So function block ID of 1, function block ID of 1. If we scroll down, this is the function block ID PDF. We keep going, we can see all of these functions now and what they mean. So you can see we're getting a function of 0, which is F block IDs. Op type is 1, which is a get. So a module on the network is sending us a message, and it's querying the F blocks that are implemented within this device. So within the PiMost, what F blocks are implemented. Currently there's not any. That's part of the application side, so it's not the hardware side. The only application we've got running that's talking to it at the moment is the MOST Explorer. That's just pretty much logging out the messages, so there's nothing more than that. So what we can do in the MOST Explorer to see something a bit more interesting come through is request the registry. So every device on the network gets this message that we're getting, and when they respond and say what F blocks are implemented, the network master creates a registry of all the F blocks that are on the network. So if we click create request registry, see a bunch of messages come through. You can then click this, and this is now a list of everything that is on my test network. So there's 4 devices, including the PiMost. So there's the PiMost, CD player, CAN/Most gateway, and then the amplifier. So you can see there's quite a few. These ones without names are manufacturer specific, so they've not followed the MOST specification. Jaguar, Land Rover have come up with their own. These ones are the ones that are following the specification to some degree. So network master there, diagnostics, amplifiers. You can see there's 4 amplifiers in total on the network. Only one of them will be the actual amplifier. Telephone, audio displayer, aux in, microphone input, AM/FM tuner. So hopefully that's been quite helpful. I'll do a quick snippet of an application that I've been working on that kind of shows you, what you can do with this data. You might be expecting to see a bit more traffic coming through, but MOST bus is a bit different to CAN bus. So CAN bus is a one-to-many, so one module will send out a message and every single module on that CAN bus network will get that message. This is all done through addresses, so only the devices that the message is intended for will see that message. So what we're missing out here is quite a bit of kind of application level stuff. To receive messages on MOST, the most efficient way of doing it is through notifications. So you could register your device with the CD player to say whenever you have a data change, then notify me, and then you'll get that message. So you could say to the CD player, give me everything, and then when it changes track, or the current track time changes, or the CD changes, you'll receive a message from the CD player with that information in it. So currently we haven't got anything registered, so we're just getting the most basic messages coming through. There is a login functionality, so if we was to put in a file name, we'll call it demo, we'll click begin login. If we request the registry again just to get a bit more traffic, click stop login. It will then download that file, so we'll save it to our downloads. If I now open that up, you can see these are the messages that is logged. You got your data, you got your telegram length, operation type, function ID. So this can be quite handy when you're trying to find out some of the data that's flying around on the network. Okay, so this is a little application I've been working on. You'll recognise this from the MOST Explorer. This is how it started out. It'll probably be separate from this application. But if I refresh this, you'll see the messages come flying in. There'll be a lot more. This is all the notifications going on. So I'm requesting notifications from the audio displayer, AM/FM tuner, amplifier, and also the network master. So if I refresh, and then you can see all of the subscriptions going on. A couple of errors. Doesn't seem to affect it. That's just calling functions that have been told that they're available, and they don't actually seem to be available. So if I show you on the test setup, you can see on there what's happening on the actual CD player. If we click onto the application, this is just a kind of demo page, just messing around, but it is all live. So this is live track data. So if I choose skip, see it skips on both. I can click on that and it'll take me to the CD player page. So I can again skip, I can turn on shuffle, go through them all, turn on repeat. I can change CD. I then go to AM/FM tuner on the CD player. and do the same on here. We can see radio text works, frequency works. I can scan for new stations, so I click scan, see it's jumped onto 91.3, click it again, see it'll go through them all. Should be able to click auto store and it'll scan through. I can go to settings. I'll put some audio settings on there so I can adjust the bass, the treble. I can change stereo, 3-channel, surround sound. Bluetooth will be next on the list, and then probably the microphone to be able to feed into CarPlay. Obviously if CarPlay was built into this app, you could have that and the audio going directly onto the fibre optic bus. So yeah, that's pretty much where it's at. Just a kind of demo of what could be possible. A huge amount more still to do on the whole MOST bus side, but at least progress is being made. Just one extra bit to add, just where to get the documentation really, if you want to start exploring it yourself or contributing to the software side, the driver side. Any contributions will be great. It's all new ground that we're covering, so the more people doing it, the better. But if you type into Google MOST Cooperation, top one is this specifications page. So if you click that, it brings you to this page. There's all different versions, to version 5, 3, 3.1, 4. I've been working from 2v5, which I think is around the year for the cars that I've been experimenting with. But your mileage may vary with that. You may need to jump to 3. I do kind of find that I think you need all the versions really to get a full overview, because each one, sometimes in the zip folders, they have archived versions. So I think in version 3.1, for instance, if the CD player has not changed since 2.5, then you jump onto the 2.5 one and use that one. There's also the MOST book, which is super useful. It's pages and pages all about the underlying protocol, the message structures, all the different MOST versions. Obviously the MOST HAT is only version MOST 225. MOST 50 and MOST 150 use different chips. I haven't even begun to think about looking into those. May do in the future, but I think most people are on MOST 25 who are looking to do this. But this is where all of the documentation is. So if we click FBlock library, which is typically the one I've been using the most, and if you go into the zip file, it looks like this. You've got system FBlocks, you've got the MOST 50 version, and you've got the O 25 version. So the O is fibre optic, so you want to stick with that wherever you can. If we go into NetBlock, which is the one that I've used in the video, it then brings you up that PDF that I used earlier. If you go back one, make sure you look inside this one. This is where a lot of the interesting ones are, and also archived blocks, which is still relevant to my Jag. You see that's version 2.5, 2.4, but there's not an updated version anywhere else. So I think that's just handy to know for anyone looking to get started.